In this video, we're going to be looking at symmetry and determining if graphs have symmetry with respect to the x-axis, the y-axis, and or the origin. Okay, so first of all, x-axis symmetry, this is the x-axis right here. That means that the top and bottom have to be equal. Okay, so that's the most easy way to look at it on a graph. The top equals the bottom. Okay, but the way to look at it more mathematically is that you can replace y with negative y and get the same thing out, or different notation, replace f of x with negative f of x. Now if this is true and they're the same, like if you put a negative in front of the entire function and it's the same as without the negative, then it does have x-axis symmetry. As for y-axis symmetry, this is the y-axis, so the left equals the right. Okay, so that's the easy way to look at it, but it's also could be looked at it this way. If x is equal to negative x, or another notation is this, f of x is equal to f of negative x. Okay, so left and right look the same, then you have y-axis symmetry. Now, origin symmetry will either have both x-axis and y-axis symmetry, or it will have neither x-axis or y-axis symmetry. Okay, so it's either both or neither, and the corners are equal to the other corners. What I mean by that is this corner and this corner look the same, and this corner and this corner look the same, then you do have origin symmetry. So if you replace y with negative y and you replace x with negative x, if both of those have symmetry, then you will have origin symmetry. Or if neither one of them has symmetry, you could still have origin symmetry. All right, let's take a look at this first one. So we've got a line here, and it asks us what kind of symmetry do we have on this. So we can see that the top and bottom do not look the same. Like this is an empty square and this is not an empty square. So the top and bottom do not look the same. So it does not have x-axis symmetry. Y-axis, does the left and right look the same? Okay, so just look at this right here. Is this a mirror right here between these two? Because this has nothing in it and this has a graph in it. So it does not have x-axis symmetry. Okay, so let's check origin symmetry. Okay, the origin symmetry says the corners have to be the same. So we've got this corner and this corner with nothing in them. That looks the same. And then this corner and this corner with a line on each one of them. So that is the same. Okay, so it does not have x-axis or y-axis, but it does have origin symmetry. Okay, let's take a look at this one. So does it have x-axis? Does the top equal the bottom? Okay, well this top and bottom over here are both empty, so that's fine. And then the top and bottom here is a mirror. Okay, so it does have x-axis symmetry. Does it have y-axis symmetry? Well, the left and right do not look the same, so it does not have y-axis symmetry. So since it only has one of the two, then it cannot have origin symmetry, but it's easy to see on the graph. This is an open corner, no graph here, but there is a graph here. And this is no graph, and there's a graph here, so the corners do not look the same. So it's just got x-axis symmetry. Okay, now let's look at this next one over here. So x-axis symmetry says the top and bottom have to be the same. So is the x-axis making a mirror of either side of this? Does the top look like the bottom? Yes, it does. So we'll say, yeah, it has x-axis symmetry. Do the left and right look the same? Is this a mirror for y-axis symmetry? Well, yes, the left and right do look the same. So it does have y-axis symmetry, which means it automatically has to have origin symmetry. But we can see the corners look the same, so it does have origin symmetry. So it has x-axis, y-axis, and origin symmetry. Okay, let's look at these. Okay, so x-axis, do the top and bottom look the same? Yes. Did the left and right of the y-axis look the same? Yes. Do the corners look the same? Yes, so it has all three. Okay, let's look at this one. Do the top and bottom look the same? Well, over here they're empty, that's fine, but here we have a graph on top, and there's no corresponding graph on bottom. So this does not have x-axis symmetry. Does it have y-axis? Does it reflect across this axis? Well, there would have to be another one of these little graphs over here like this for it to have y-axis symmetry, so it does not. Last question, does it have origin symmetry? Do the corners look the same? Well, there's a graph in this corner, but there's no graph over here. So this corner does not look like a mirror of that corner. So it does not have origin symmetry. So this one's going to be none of these. It has no symmetry whatsoever. Okay, and then the last one here, do the top and bottom look the same? No. This should be a graph like down here and another graph up here for the top and bottom look the same, so they do not. For y-axis, do the left and right look the same? Well, no, there would need to be a graph here for this one, and there would need to be a graph here for this one, so no y-axis. Does origin symmetry exist on this graph? Do the corners look the same? Well, if you take this right here and you flip it across the x-axis and then the y-axis, it would be exactly like this right here. Okay, what I mean by that is if you took this and flipped it down and it changed into this, and then you took this and flipped it over, which changed it into this, then it would be the same graph. So this does have origin symmetry. The other two corners are empty. Okay, so no x-axis, no y-axis, but it does have origin symmetry.